So have you ever thought about that number, 2.1 children per woman? The one we always hear is needed to, keep the population stable.
Yeah, the replacement rate.
Exactly. Well, today we're diving into some really interesting new research. It suggests, actually, that 2.1 might not be nearly enough for long-term survival.
That's right. We're looking at a study just published in PLOS One. The lead author is Takuya Okabe from Shizuoka University.
Okay.
And they've used some, well, pretty sophisticated models that really challenge that standard 2.1 figure.
Right, so let's unpack it. 2.1, the idea is basically one kid replaces each parent, plus a little extra to account for people who die young, right?
That's the standard thinking, yes.
Right.
But what this new study highlights is, well, life isn't that neat. It's messy.
How so?
Well, not everyone has exactly 2.1 kids. Some have more, some have none. People's lifespans vary, and even the ratio of boys to girls born isn't perfectly fixed.
Ah, okay. Random chance.
Precisely. These random fluctuations, the study argues they're often overlooked in the simple 2.1 calculation, and they can really add up, especially in smaller population groups.
And this is where it gets really interesting, isn't it? Their research points to a much higher number, closer to 2.7 children per woman, needed to, reliably avoid extinction.
Yeah, 2.7, that's quite a jump.
Why such a big difference?
So they used mathematical models. Think of them like simulations running populations forward over many, many generations.
Okay.
And what these models show is that those random events, someone having 0 kids, another having 5, variations in who survives, the sex ratio lottery, they can cause family lines to just fizzle out, purely by chance.
Even if the average fertility looks okay.
Exactly. So that higher rate, the 2.7, it acts kind of like a buffer, a safety net against all that unpredictability, making it more likely that enough family lines actually continue down the generations.
Wow. And it wasn't just about the total number of people, right? There was something surprising about the sex ratio, too.
Yes, that was fascinating. They found that having a slightly higher proportion of female births actually seems to reduce the extinction risk.
More females born helps more family lines survive. How does that work?
Well, fundamentally, population growth potential is often more linked to the number of females. So a slight bias there helps ensure continuity.
Okay, that makes sense.
It might even connect to observations. Sometimes during really harsh conditions like wars or famines, there's a slight uptick in female births. It could be a sort of evolutionary hedge against collapse.
Huh. That's wild. So for big countries today, this doesn't mean extinction is around the corner.
No, not for large populations, not immediately. But the finding still implies that even in those large groups, most individual family lineages, your specific family tree and mine, are statistically likely to fade out eventually.
That's quite a thought when you think about ancestry and family history.
It really is. And then you look at global trends. The UN figures put the current global average fertility rate around 2.3.
Still above 2.1,
but below this potential 2.7 threshold. And the projection is that the global average will actually dip below 2.1 by mid-century.
So we're kind of heading in the opposite direction of what this study suggests might be needed for true long-term sustainability.
Seems that way. One of the researchers, Diane Carmelisa-Quaresma, basically said that given all the inherent randomness, the stochasticity in births, deaths, sex ratios, you really do need a fertility rate above that simple replacement level to sustain a population over the long haul.
It makes you rethink what sustainability even means in this context. It's not just headcount.
Absolutely. It touches on the survival of, entire cultures, languages, traditions, all tied to these family lines.
And maybe even how we approach conservation for endangered species, setting those target birth rates.
That's the other potential implication, yeah. Are the targets high enough to account for this randomness?
So for you listening, the big takeaway here seems to be that old 2.1 number. It might be a significant underestimate because, life is unpredictable.
Right. It doesn't fully capture the effects of random chance over time. And that finding about female-biased birth ratios possibly being protective under stress, that's a really intriguing twist.
Definitely. It leaves you with a pretty big question, doesn't it? If this research holds true, what are the real long-term consequences for societies with falling birth rates? Not just for the overall population size,
but for the continuity of all those individual family stories, those cultural legacies that make up our world. It's something to think about.
A powerful thought indeed. Thanks for walking us through this.
My pleasure. Fascinating stuff.